And now we go on to the laws of thermodynamics, beginning with the zeroth law, which states that if there is a body, a system A, and there is another body B, and this has a temperature TA, that means this is in equilibrium, and this has a temperature TB, that means this is also in equilibrium. So then if TA is equal to TB and there is a third body C whose temperature is TC, and if TA is equal to TC, that means the temperatures are equal, then the law says that temperature of B is equal to temperature of C. That if two bodies have the same temperature with one another and with another body separately, then these two have the same temperature. It sounds quite obvious. It helps us in defining a temperature scale, and in many cases we exploit this principle unknowingly in making temperature measurements. I'll give one example on that. If there is, say, steam or hot substance or an acid or something like that flowing through a pipe, and you want to measure its temperature, we cannot just stick something into it, especially a mercury thermometer, and hope to get the value. So what one does is to drill a hole and weld a pipe which is closed at one end in the wall of the tube, and this is all welded around. So this is a tube welded into this pipe into which the substance is flowing. Its temperature is, say, T, and we want to measure it. And so what we do is we put our sensor inside this, and this could be any of these type of sensors that we have. Say a resistance temperature detector. It could be here or it could be in contact with this inside surface of this tube, and this little thing is filled with a liquid. And what we measure is from this instrument is the temperature of this part of this instrument, which we will call, say, TI, temperature of the instrument. And we say that this temperature is equal to the temperature of this tube, which in turn is equal to the temperature T. So the tube temperature is TB. Then we say that we know that T is equal to TB, and I'm measuring TI, which is equal to TB, and so my instrument is giving me the temperature of the fluid. This type of an arrangement is very, very common. You will see it everywhere, and this is called a thermowell. And that's where we have used the zeroth law of thermodynamics. With this, we also define a temperature scale, although that also comes a little later on, where the accepted temperature scale now is that absolute zero is minus 273.15 degrees Celsius, and historically there have been two set points. One used to be the triple point of water. We'll learn that a little later, which is 0.01 degrees Celsius, a temperature at which liquid, vapor and solid water can exist in equilibrium. And at ambient conditions, 1 atmosphere, the boiling point of water, 99.6 degrees Celsius, and then we divide these. So we use the absolute scale of temperature, which basically tells us that when the substance goes to 0 Kelvin, it has no energy, and so we associate 0 with the energy and 0 with its temperature. That becomes your absolute temperature scale. And 1 Kelvin is 1 by 273.15 of the triple point of water. That's what it